Hey guys, what's going on? It's Dave with Evil Eye Games. Today we're going to continue on with our series in creating a third-person cover shooter. And today what I want to go ahead and add to our project is the ability for our weapon to overheat. We're going to have audio-video feedback of the weapon overheating. And I want to create a zoom effect when we aim with our weapon. And finally, I want to add some weapon recoil. So first we're going to start with our weapon overheating. So to start off with, I'm going to go into our weapons folder, into our player weapons, and I'm going to open up our base weapon blueprint. Now we're going to need a series of variables in order to handle our weapon overheating. So I'm going to go ahead and I'm going to add a variable, and this is going to be called heat current, and it's going to be of type float. I'm going to add a second variable. This is going to be heat max. I'm going to add a third variable, and I'm going to call this heat reduction rate. I'm going to add a fourth variable, and this is going to be the heat buildup rate. And I'm going to go ahead and compile. And then I'm going to set the default values for our heat max. I'm going to set this to 15. I'm going to set the value of our heat reduction rate to 3. And I'm going to set the value of our heat buildup rate to 1. And then I'm going to create a final variable. I'm going to call this weapon overheated. And this is going to be of type bool. So now that we have our variables in place, I'm going to go ahead and I'm going to create a new function. And I'm going to call this function reduce heat buildup. And this function is going to have one input. I'm going to call this input delta T. And it's going to be a float. And from our initial execution pin, I'm going to drag off and we're going to add a sequence. And from our then 0 pin, we're going to drag off and we're going to add a branch. And we want to check our heat current to see if it is greater than 0. So I'm going to drag our heat current variable. And we'll get a greater than. And we'll plug it into our branch. Next, we're going to add a new branch in. And we're going to connect this from our true of the previous branch. And we want to actually go ahead and calculate our current heat after it's been reduced. So we're going to go ahead and get our heat current. And we want to subtract from it. And the amount we want to subtract from it is going to be our delta T. And we're going to multiply that number times the heat reduction rate. And then we're going to take the result of the subtraction and we're going to check to see if it is less than or equal to 0. And we're going to connect that to our branch. And if our heat current is less than or equal to 0, we're going to go ahead and set our heat current to 0. We don't want the heat current to fall below 0. And we're also going to go ahead and set our weapon overheated. And we're going to want to set that to false. And then if our heat current isn't less than or equal to 0, we're going to go ahead and copy the set heat current. And we'll connect it up to our false. And we want to plug in the value of our subtraction here. Now, when our weapon has been set to not overheated, we want to create an event that is going to go ahead and update necessary parties so that we know the weapon is no longer overheated. In particular, we want to update our heads-up display so that it knows that our weapon is no longer overheated. And to do this, I'm going to use a dispatcher. And a dispatcher is similar to an interface. However, a dispatcher doesn't need a reference to what it's sending the data to, like a interface does. A dispatcher more or less sends out a broad message, and anything that implements the dispatcher will automatically receive the message. So to the left here, under Event Dispatchers, I'm going to go ahead and add an Event Dispatcher. And I'm going to call this Weapon Overheated Dispatcher. And I'm going to create one input for this. And I'm going to call it Weapon Overheated. And it's going to be a Boolean. So I'm going to go ahead and I'm going to drag our Weapon Overheated Dispatcher onto our graph. And I'm going to select Call. And I'm going to plug this in to our set Weapon Overheated. And I'll connect the value of our variable to our input. And then we're going to go back to our sequence node. And we want this then1 to update the heads-up display as well on the amount of heat that the weapon has, specifically the percentage of our maximum heat that is currently built up. So I'm going to add a second dispatcher, and I'm going to call this Weapon Overheat Percent Dispatcher. And I'm going to go ahead and add an input to this. And I'm going to call this Overheat Percent. And it's going to be a float. And I'll go ahead and I'll drag our Weapon Overheat Dispatcher onto our graph, and I will call it. And we're going to plug our then1 pin into our dispatch call. And we're going to want to send the percent of our heat max to the dispatcher. So we'll get our heat current, we'll get our heat max, and we'll divide our heat current by our heat max, and plug the results into our overheat percent input. And that's going to complete our reduce heat buildup function. So I'm going to go ahead and compile and save, and go back to our event graph. And I'm going to go ahead and drag our reduce heat buildup function onto our graph next to our event tick. And I'm going to drag the execution pin from our event tick into our reduce heat buildup and connect our delta seconds into our delta t. And I'll go ahead and compile and save that. Next, we're going to have to create a way for our weapon to actually build up this heat. So I'm going to create a new function. And I'm going to call this function Fire Heat Buildup. And so we're going to need to calculate how much heat is accruing on the weapon. So I'm going to go ahead and drag out our heat current. And I'm going to drag out our heat buildup rate. And we're going to add these two together. Next, we want to run a check against these to see if it's greater than our maximum heat. So I'm going to drag out our heat maximum. And then from our addition pin, I'm going to drag out and get a greater than or equal. And we'll compare it against our heat max. And we'll go ahead and add a branch. And we'll connect that into our branch. And so if the result of our heat current plus heat buildup rate exceeds the maximum heat, we're going to go ahead and we're going to set our heat current. And we're going to set this to our heat max value. And at this point, since our weapon has reached maximum heat levels, we're going to go ahead and we're going to set our weapon to the overheated state. And we're going to set weapon overheated to true. And then we're going to go ahead and drag out our weapon overheated dispatcher. And we're going to call that. And we're going to set the input to the value of our weapon overheated. And then if this value doesn't exceed our maximum heat, I'm going to go ahead and I'm going to copy this heat current value, and we're going to go ahead and set it to the result of our addition. And then I'll just neaten things up a little bit. And then I'll go ahead and compile and save. And then back in our event graph, we're going to go ahead and call our fire heat buildup at the end of our fire weapon. So every time we end up running the fire weapon event, it is going to go ahead and add heat to the weapon. Now, the dispatchers will be taking care of the visual feedback on our heads-up display. I also want to add in a audio feedback as well. So I'm going to go ahead and we're going to add a new macro. And I'm going to call this macro overheat alarm. Now, if you haven't used macros before, they have inputs and outputs just like functions, but they don't come default with execution pins. So I'm going to click on the input, and we're going to go ahead and add a new input. And I'm going to call this EXEC. And under the type, there is the EXEC execution pin. And then we're going to do the same thing for the output. We're going to add a new output, except I'm going to call this EXEC out. And we're going to make sure it's an execution pin as well. And off of our input execution, I'm going to get a sequence. And then from our then 0 pin, we're going to put in a branch. And we only want this to run if the weapon is overheated. So I'll get our weapon overheated variable. And I'll plug that into our condition. And if our weapon is overheated, from the true pin here, I'm going to drag out and I'm going to get another sequence. And from the then 0, I'm going to drag out and we're going to search for a do once. And then from our then 1 pin, we're going to drag out and we're going to search for a delay. And I'm going to set the duration to 0.5 and connect the completed to the reset on our do once. And what this is going to do is every time our macro is run, when we get to this point in the sequence, it's going to run into our do once. And the do once is like a gate. So after it gets told to execute, it won't execute again until the reset pin is triggered. So every half second, the reset pin is going to be triggered. And we can use this to create a cycling alarm effect. And then from our original sequence, we're going to connect our output to the then 1 pin. And I'll just drag this over. Now, after our do once, we want it to actually play a sound. So we're going to have to go ahead and get a sound. So I'm going to go to our launcher. And one thing I really like to do is create a scratch project so that I can move files into it. Especially in the case of something like an audio project where there's tons of audio files in there. You don't necessarily want all the audio files. So I'm going to go to launch in Unreal Engine. And we're going to create a new project. And we want it to be blank with no starter content. And I'm going to name this Scratch. And we'll go ahead and create the project. And now that the project is created, I will go ahead and open up our sources panel over here. And we'll go back to the launcher, and I'm going to be using the Pro Sound collection that's available on the UE4 marketplace for this. So if you want to follow along, you can use the same sounds. Or if you have sounds that you sourced from somewhere else, you can use any array of sounds that you want. So I'm going to go ahead and add our Pro Sound collection to the project. And I'm going to select our Scratch project, and I'll click Add to Project. And once it finishes adding it to our project, we can go back into our Scratch project and we'll see the folder for our Pro Sound collection. Now I've already selected a sound from here, and I'm going to go into the Sci-Fi folder, and I'm going to select the Sci-Fi code fail 06. Now this package already comes with the sound cues as well as the waves, and I'm going to go ahead and I'm just going to transfer the wave over. So I'm going to right click on the wave, which is the black icon with the little sound waves on it. I'm going to right click. We're going to go to Asset Actions, and we're going to migrate. And it's going to show you exactly what it's going to migrate to your other project. So we'll click OK. And then we have to find the content folder for the project we want to migrate it to. So in this case, I have my third person cover folder here, and you want to select the content folder and click OK. And you'll get a message saying the content migration has completed successfully. So we'll go ahead and close this project out, and we'll go back to our project. And in our main window, we're going to see that there is the folder for the Pro Sound collection. And I'm going to go ahead and I'm going to rename this. And I'm going to call this Weapon Overheat Sound. And in our main content folder, I'm going to create a new folder. And I'm just going to call this Sounds. And then I'm going to go ahead and move our Weapon Overheat Sound into our Sounds folder. And we'll get rid of the Pro Sound Collection folder. And then we're going to have to make a sound cue out of this. So I'm going to go ahead and right click in our folder. And we're going to go to Sounds. And we're going to select Sound Cue. And I'm going to call this Weapon Overheat Sound _ cue. And I'm going to go ahead and open up our sound cue. And we can go ahead and grab the sound file and drag it directly into our sound cue. And then we're just going to plug it into the output. And we'll go ahead and save that. And close out of it. And then back at our weapons blueprint, after our do once here, I'm going to drag from our completed, and we're going to go ahead and search for play sound. And I'm going to select play sound 2D. And then for the asset, I'm going to search for the cue that we just created. So weapon overheat, and I'm going to select the sound cue. And I'm going to go ahead and compile and save. And then we'll go back into the event graph. And I'm going to drag out our overheat alarm into our event graph. And I'm going to connect this behind the reduce heat buildup from our event tick. So I'll go ahead and compile and save that. So next we're going to actually implement the visual feedback for our weapon overheating. So I'm going to go back to our main window. We're going to go into our HUD folder. And we're going to open up our gameplay widget. And in our palette, I'm going to go ahead and search for a progress bar. And we're going to go ahead and drag that onto our canvas panel. And then I'm also going to search for text. And I'm going to drag the text onto our canvas panel as well. And then I'm going to select our progress bar. And in the details panel, I'm going to go ahead and name this weapon overheat bar. I'm going to go ahead and set the anchor to the center of the screen. And then for our position X, I'm going to set this to 0. Our position Y, I'm going to set to positive 50. The size X, I'm going to set to 150. And the size Y, I'm going to set to 15. The alignment, I'm going to set the X alignment to 0.5. And you'll see that we have a progress bar that's somewhat below our crosshair and centered on the screen. And then we're going to go into the style. And then I'm going to go to the background image. And I'm going to select the tint. And I'm going to drag the value of the contrast all the way down. And I'm going to set the alpha to 0.25. And I'm going to hit OK. And then I'll make the background to our progress bar dark, like a charcoal gray that you can see through. And then under progress, I'm going to go ahead and set the bar fill type to fill from center. And then I'm going to select the fill color and opacity. And I'm going to make this red. So I'm going to set the R channel to 1, G to 0, B to 0. And I'm going to set the alpha for this to 0.5. I'm going to hit OK. And then under progress here, we can change the variable so that we can show what it's going to look like when it fills up. And that looks pretty good to me. So next, I'm going to select our text block that we created. And I'm going to name this Weapon Overheat Text. And we want to check on the box next to that is a variable. And then I'm going to go ahead and I'm going to anchor this to the center of the screen. And we're going to set our position X to 0, our position Y to 68, our size X to 150, our size Y to 17, and then I'm going to set the X alignment to 0.5. And in the text here, I'm going to type in weapon overheated. Then I'm going to change the color and opacity here. I'm going to set this to red, so I'm going to zero out the green and the blue channel. And we'll set the opacity to, let's say, 0.5. And then I'm going to set the size of our font to 12. And in justification here, I'm going to align to the center. And then we're going to go ahead and we're going to go into our graph. And then when we create our widget, we want to go ahead and assign those dispatchers from our base weapon. So I'm going to right click and I'm going to go ahead and get player character. And we're going to go ahead and we're going to cast to our 3P character. And then we want to get a reference to our equipped weapon. And then from our equipped weapon, we want to search for the two dispatchers that we ended creating. So there was the percent dispatcher, and we want to bind event to weapon overheat percent dispatcher. And then we want to drag off from our equipped weapon again, and we want to find that weapon overheated dispatcher, and we want to bind event to weapon overheated dispatcher as well. And then we're going to drag off of the event pin here, and we're going to add a custom event. And I'm going to call this update overheat percent. And then we're going to drag off the event for our overheated dispatcher. And we're going to add a custom event. And we're going to call this update overheated text. And so what we're going to want to do now is we're going to grab our weapon overheated bar reference. And we want to set percent. And we'll go ahead and connect the execution pin and our overheat percent to our in percent. And then for the update overheated text, I'm going to drag out a reference to our weapon overheat text. And from our update event here, we want to create a branch. So if our weapon is overheated, we want to show this text, and if it's not, we want to hide it. So from our weapon overheat text, I'm going to drag out and I'm going to search for set visibility. And I'm going to make a copy of that. And we'll connect true to one and false to the other. So in the event that it's true, we want this text to be visible. In the event that it's false, we want it to be hidden. And then we want to make sure the defaults for these percent bar and the overheat text are set up appropriately. So in our designer real fast, I'm just going to grab the progress bar and I'm going to set the percent to 0. And I'm going to select our weapon overheated text, and under behavior, under visibility, I'm going to set to hidden. So we'll go ahead and compile and save, and we can go ahead and test it. So we have our percent bar on the screen and no overheated text. And if I start firing the weapon, the bar will start filling up. And when it gets to its maximum amount, it'll show the weapon is overheated. At this point, we can still fire. So we're going to have to go back into our base weapon. And in our event graph under fire weapon, I'm going to drag this off to the side, and from our fire weapon, I'm going to add in a branch. And the condition is going to be our weapon overheated, so we're going to go ahead and get that. And we're going to plug that into our condition. And we want the weapon to fire when weapon overheated is false, so we'll plug our sequence of functions from our fire weapon into the false pin. And if it's true, I want to go ahead and call on the stop fire weapon event. So I'll go ahead and compile and save, and we'll hit play. And if we fire our weapon, the bar fills up, and then when it gets to the overheated state, I can't fire the weapon and it stops firing. And then once it is no longer overheated, I can go ahead and fire the weapon again. Now the next thing I'm going to do, since we're in our weapon, is I want to add recoil to the weapon. So on our event graph here, I'm going to right click and I'm going to add a custom event. And I'm going to call this recoil. And from our recoil event, I'm going to drag out, and we're going to search for a timeline. And we're going to go ahead and add a timeline. And I'm going to call this our recoil timeline. And I don't want this actually plugged into the play event, so I'm going to break that link. I'm going to add it to the play from start. And then we're going to have to edit this timeline. So I'm going to double click on our recoil timeline. And towards the left here, I'm going to add a float track. And I'm going to call this recoil amount. And then for length, I'm going to set this to 0.25. So it's going to be quarter of a second long. And on our graph here, I'm going to right click and add a key. And I'm going to do that a second time, so there's two keys. And I'll left click on the first key. And I'm going to set the time to 0. And the value is going to be 0 as well. The second key, I'm going to set the time to 0.05. And I'm going to set the value to 1. And then I'm going to go ahead and add a third key here. And I'm going to set the time to 0.25 and the value to 0. And to the left of where we set the time and the value here, there's a zoom to fit button for both the vertical and the horizontal. And what we're doing here is this timeline will basically over the quarter of a second change the value from 0 to 1 and then back down to 0. So we can go ahead and close out of our timeline. And we're going to add two new variables. First one is going to be vertical recoil. And it's going to be a float. And we're going to add a second variable, which is also going to be a float. That is going to be our horizontal recoil. And what our recoil is going to do is it's going to add input to our player controller. So to the right here, I'm going to right click and we're going to get our player controller. And from our player controller, we're going to drag off and add a pitch input. And we're also going to drag off from our player controller and add a yaw input. Now, to figure out the values that we're going to add here, I'm going to compile so that we can set the defaults for our vertical recoil and our horizontal recoil. And for the vertical recoil, I'm going to set this to 0.05. And our horizontal recoil, I'm going to set to 0.01. And we're going to solve our vertical recoil first, so I'm going to get our vertical recoil. Now, one thing to keep in mind is the up direction is a negative number and the down direction is a positive number. So to make this easier when we configure the weapons, I'm going to put in a multiplier here. And we're going to multiply this by -1. So that way we don't have to remember when we're setting up our weapons that if we want it to kick upward, we have to put in a negative value. So that's just going to make it easier for us. And then I'm going to right click in the graph and I'm going to search for a lerp. And we're going to go ahead and connect the result of our multiplication to the B. And then we're going to connect our recoil amount into the alpha. And what this lerp is doing here is it's solving for a value between the A pin and the B pin based on what the alpha value is. So we're going to connect the return value in here to the value of our pitch input. And I'm just going to move these up. And we want to connect our update pin to our add pitch input here. And then I'm going to go ahead and I'm going to copy our lerp. And we're going to get our horizontal recall. And we're going to plug that into the B pin of our new lerp. And we're going to connect our recoil amount from our timeline into the alpha. And the result into our add yaw input. And then finally, we want to go ahead and call this recoil event. So at the end of our series of functions, when we fire the weapon, after we fire our heat buildup, we're going to go ahead and call that recoil event. So at this point, we can compile and save, and we'll go ahead and test it out. So when I hit the fire key, our weapon is kicking up and to the right. And as always, you can play with these values. And lastly, I want to go ahead and add some zoom to when we use the aim button. Now, I'm going to put the value of the zoom into our base weapon, so that way, if we have different weapons with different levels of zoom, or if, say, you want to add an attachment to a weapon that changes the zoom, it can pull it directly from our weapon. So while in our base weapon here, I'm going to add a new variable. And I'm going to call this zoom FOV. And we'll compile. And I'll set the default value to 45. And we can go ahead and save. And we're going to have to go into our 3P player character. And in our event graph here, I'm going to right click and I'm going to add a custom event. And I'm going to call this event set FOV. And it's going to have one input. It's going to be a Boolean. And I'm going to call this is aiming. So I'm going to go ahead and add in a branch. And I'm going to connect our execution pin and is aiming to our condition. And then we're going to go ahead and we're going to add in another timeline. And at the bottom, there'll be add timeline. And I'm going to call this zoom timeline. And we're going to want to connect the true to our play, and we're going to want to connect the false to our reverse. And we're going to go ahead and double click on our zoom timeline, and we're going to add a float track. And I'm going to right click and we're going to add a key twice. And the aiming animations that I have in there are half a second. So at the top, I'm going to set the length to 0.5. And I'm going to select our first keyframe. And I'm going to set the time to 0. And the value is going to be fine at 0. And then our second keyframe, I'm going to set the time to 0.5. And the value is going to be 1. And then we'll go ahead and fit this to our graph. Now I want it to kind of smooth out the function here instead of being a straight line. So I'm going to right click on our first keyframe and I'm going to set this to auto. And what you're going to see is that the track will become a curve instead of a linear line. And then we can rename this track here as well. I'm going to call this zoom time. And I'll go ahead and close our timeline. And now we're going to grab the reference to our equipped weapon. And we want to get the zoom FOV. And then we want to get a lerp as well. And we're going to plug this into the B pin of our lerp. Now what we're going to be doing is we're going to be setting the field of view for our camera. The default field of view is going to be 90. So in the alpha pin here, I'm going to set this to 90. And then our field of view for our zoom we set to 45. So we'll go ahead and connect our zoom time to our alpha. And then we're going to have to get a reference to our camera. So from our components in the left-hand side there, I'm going to drag out our camera. And from there I'm going to drag out and I'm going to search for set field of view. And we're going to plug our return value from our lerp into our field of view and connect the update pin to the set field of view. And I'm going to go ahead and I'm going to select all this and we're going to put a comment box in on it. And I'm going to call this set aim FOV. And we could go ahead and compile and save. Lastly, we have to call this event. So we're going to open up our player controller. And we're going to go to where our aim button is. So we're going to pull out a reference to our player character. And then we're going to call the set FOV event. And we're going to want to create one for each the is aiming and is not aiming. And we'll plug the value of our set is aiming into the is aiming input on our set FOV. And I'll just expand the comment box around there. And we can go ahead and compile and save. And remember to connect the target up. And we can go ahead and play and test it out. So if I hit the aim button, we have a smooth zooming in action. And if I let go, it has a smooth zooming out action. And then as well, if I let go of the zoom in the middle of the zoom, it will transition smoothly between the zoom and the not zoomed position from where it currently is. So that's going to complete this video. If you have any questions or comments, go ahead and leave them below. And as always, thanks for watching.